Hi, and welcome to Chapter 6. In Chapter 6, we're going to discuss the concept called normalization. And normalization is a really important concept in computer or in database design because it ensures that your data doesn't have any redundancies or anomalies. So it's really, really important. We do normalization after we finished writing our ERDs, so this is perfect. We're just going to go straight from writing our ERDs last chapter to normalization. Let's get started. The first thing I want to do is cover a couple of terms. So we're going to be using these terms throughout this chapter, and I want to make sure that you understand what they all mean. The first one, of course, is normalization. It's just the process of reducing or eliminating data redundancies. When you have your data, you want to try to make sure that you don't have redundancies in it, because obviously if you have redundancies, you have to update in two places and it can make your data incorrect. Back to our very first chapter, the most important thing about your data is that it's accurate. If you don't get accurate data, it doesn't help. So normalization is just something we do while we're designing after we've created our ERDs to make sure that our data is good, that everything is designed well in the database. There's also the concept of denormalization, which we do at the end of our normalization process, which is where we add back data redundancies or other changes in our database design to increase our processing speed. If you over normalize your data, your processing speed can get very, very slow, and it can cause some significant issues of getting your data out fast and efficiently if you have too much normalization. So we go through this whole process of normalizing, and then we turn around and we go back and we unnormalize or denormalize a little bit of it just to make sure that everything's good. Couple of things in normalization. Because of the way normalization was created, we sometimes use the word prime to refer to our primary key. So our prime attribute would be our key attribute. Our non-prime would be our non-key attributes. Just a heads up while you're reading the chapter, the word prime and the word key, primary key, can be used interchangeably. There's a little image here of first to second to third to fourth normal form. These are the different forms that we use in creating our normalized data. And we're going to start with first, and we're going to move our way through it. So it's kind of a process. We start with step one, going into first normal form, and then we move to second, and so on and so forth. But you'll understand when we get through it. So you may wonder, why do we need to normalize? We already did our ERD. Everything's fine. We did our business rules. What's the point of this? When you're normalizing, you need to take into account that some data redundancy is actually desired or necessary. We have to put it in. And it's desired that way because we understand how we're going to get our data back out of the database. Remember, the end user is always the thing you're thinking of. And we might need that processing speed to be faster, or we want our design to be faster or more simple. So sometimes adding data redundancies, you give up a little bit in your perfect design so that the end user is happier, so that the data comes out faster, so that it's easier to understand. Normalization is designed to eliminate unwanted or undesired redundancies. So essentially this is something where if you have a redundancy that's in there but you want it, that's okay. If you don't want it, that's okay too. We just want you to be aware that it exists. It also is going to reduce your inconsistencies and eliminate your data anomalies. So while you're designing your database, we start from the beginning. We get the information from the client. We call this raw data. It might be in the form of a spreadsheet, which is what they've been using. So you have a client, they come in and they're like, hey, here's the spreadsheet I've been using for 20 years. Can you make it into a database? And you're like, great. Okay, cool. Yeah, let's take that and go play with it. So you get your description from the data. Sometimes it's just a description in paragraphs, and sometimes it's some raw data that's in an Excel spreadsheet or even files. Then you go through and you define your business rules. We've talked about this. We've already covered our business rules. Go from our business rules to create our entities and our relationships and our attributes. We create our ERDs. And that gives us kind of a visual as to what we think our database is going to look like. So we have an ERD in our hand while we're starting to normalize. The process of normalization has a base goal in mind, which is all of your tables represent a single entity or a single subject or a single noun. They're each a single item. There's not any combinations in a single table. Each row column intersection, which you could call a cell, is a single value, one value. There's no groups, there's no multi-values, it's single values. Each data item is stored in only one table, which means you don't have duplication of data across multiple tables. You don't want to have the person's name in 3 different tables. You only want it in one, and you want to be able to move on from there. This one's a little confusing. All non-prime attributes are dependent on the key and nothing but the key. So remember our primary key, that's our prime attribute. So our non-primary keys are all dependent on that key, which means from the key, I can get to all of the values, and all of the values are dependent on that key. And they all go back and forth with dependency. We're going to get a little bit more into dependency in just a second. And then we want to make sure that if we insert or delete data, it's not going to cause anomalies. It's not going to cause problems. Sometimes if your relationships are really closely tied and you delete records from one table, it can blow other things up. So we want to try to avoid doing that. And by creating our normalized data, that's going to give us that result. Again, we go from first to second to third to fourth. Fourth, really we don't get into. I'm going to explain it. I'm going to explain what it is, but most business rules stop at 3. So we go first, second, and third normal form, and then we kind of stop. There's a little description here of the 5 forms. There's also voice cod, which is BCNF, which is another type of normal form. From the description here, which is also in your book, you can see that you first create normal form, and then second normal form is first normal form plus something. And third normal form is second plus something. And fourth is third plus something. So all of them are tied to each other and they're related. So you have to keep track of which step are you at. Before we get started on our steps, let's discuss the word dependency. So we're going to refer to dependency a lot because dependency is the thing that we use to define whether or not we're in the right form. First, we start with basic functional dependency, which simply means that the attribute is dependent upon the primary key. So we should have that already because we have a primary key and we understood the uniqueness of the primary key and the fact that the primary key can get us to the rest of the values. The rest of the values are dependent on that key. We also have the concept of partial dependency. So when you're looking at your data, if an attribute is only dependent on a portion or a subset of the primary key, this happens if you have a composite key, and it's usually pretty obvious. If I had a subset of data that had a project and an employee, I might have some employee information that's dependent upon the employee and some project information that's dependent upon the project. These are partial dependencies. So they're only dependent on half of the primary key or a subset of the primary key, recognizing what those are. There is also the concept of a transitive dependency, which is an attribute that is dependent upon something that isn't even a key. It's another attribute. So I might have a primary key and then I have an employee number, an employee name. Well, the employee name would be dependent upon the employee number, but that's not a key. That's not a good way to do this. This is called transitive, which means it's dependent upon something other than the key. Sometimes those are a little harder to see, and you may not recognize them right away because of the way they can be entrenched in your data. So we're going to discuss and show examples of how you can see those. The example that I have here is that a job title and a salary could both be 2 non-key attributes in your data fields, but the salary is actually directly dependent upon the job title. So those are transitive. It's related to something that is not the primary key. All right, so let's just jump right in. Step 1, first thing we have to do is convert our data into first normal form. So first normal form is the first step in normalcy, in trying to normalize our data. And to put it into first normal form, there are 3 things that we have to do. We have to find and eliminate any repeating groups. We have to identify our primary keys, and we have to identify our dependencies. So let's start with breaking up our groups of data. As you can see from the piece of information that we have here, we have an employee number and an employee name, but we have groups of data in there. That's not going to work. We're not going to be able to do that. The user has given us the project number and the project name, and then pieces of information that are related to the project in this data set. But they're big groups. They're not individual entities. So we have to break those up. We can see now that we could do our employee name, our employee number, our job class, charge per hour, and hours billed, break those into individual fields, and just duplicate our project number and our project name for each one of those. As opposed to trying to combine data like they have done here, we actually want to repeat those groups for this stage. And we're going to end up with project number and project name repeated. Once we've done that, now we need to step back and go, what are the primary keys? So if you looked at the raw data, you might think the primary key was the project number because that was the first field and everything was kind of grouped by that. But if you look at the data after you've broken up your groups, you'll see Project number doesn't cut it anymore because we have 6 values for the same project number. That can't be a key. It's not unique. So we need to look at our data and figure out what do we think the primary key should be here. Okay, we got project number, name, employee number, employee name, job class. Well, maybe there's only one job class per project, but maybe there's not. Let's actually just go with employee number. So we're going to look at this and go employee number and project number, because each employee can only be one job per project. He can't take on both the database designer and the electrical engineer of the same project, even if he could. So we're going to break those into our primary key of our project number and our employee number. Okay, cool. Now that we've recognized that's a primary key of our data, let's go look at the rest of our dependencies. So first we look at our primary key dependencies, and we see that the project number, employee number, everything else can be gotten from those 2 pieces of information. However, there is also the relationship between the project number and the project name. So the project name is directly related to the project number. So that is a partial dependency. The employee name, class, and hourly rate, those are directly related to the employee number. That's a partial dependency. Then we can see this extra little thing, the job class and the charge per hour. The more you look at the data, and this is where it's a little bit more entrenched, you can see that if you're a database designer, you get 105 an hour. If you're an electrical engineer, you get 84. Wait, every electrical engineer gets 84. Every system analyst gets 96. So wait, is that hourly rate directly related to the job class? Turn around and ask your client, hey, is this related? And he's like, well, yeah, obviously, all the database designers all get 105, and that's just what they get. And you're like, oh, okay, that's a transitive relationship. So we're going to talk about those. Now that we've kind of looked at those, let's look at what our diagramming looks like. So this is our dependency diagram, and it's the first one we're going to look at in first normal form. We just have all of the fields listed out, lined out, just as they were in the table on the previous screen. We want to identify our primary keys separately from the rest of our fields. So in this case, we've made them yellow as opposed to the blue that we have for the rest of our fields. It doesn't matter if you pick yellow and blue, you could pick red and green. Just make your primary keys a different color and be consistent. So as you design your diagram, don't change the color to make it red and then green and then blue and then yellow. Always make your primary keys whatever color you want to make those primary keys. We also like to underline them just to make it excessively clear these are primary keys. So primary keys, again, really, really important part of databases. We want those to be separate. Then we have these cute little arrows, and you should be so happy with arrows because you've done so much of them with your ERDs up to this point. So with our arrows, we are going to show that coming from a key or a dependent value, or a dependent value, that we're going to have other values that are dependent upon it. So we can start with our 2 primary keys, our project number and employee number, and show that every other field in the table is dependent upon those 2. And so our arrow, or in this case, we can show the arrow starting from those 2 primary keys and going into all of the other keys. Then we're going to look for our partial dependencies. So we have our project number, which goes to our project name. So we have that partial dependency there. And then we have our employee number going to our employee name, job class, and our charge per hour. But don't forget, we also have that extra little transitive dependency hanging out there. That is the job class to the charge per hour. We're going to throw that in as well. And we're labeling all of these as partial dependency or transitive dependency, just so that we can use that piece of information on the next step. So at this point, in our first normal form, we have all of our fields listed out. We have our primary keys identified, a different color and underlined, and we have arrows with labels describing dependencies, either your base dependencies off your primary key or your partial or transitive dependencies. All right, then we move on to step 2. To be in step 2, you have to start from step 1. So we're going to start with the step 1 graph that we used in the last slide. Step 2 is a first normal form diagram with no partial dependencies. So this is why it's important that we labeled them. We know which ones our partial dependencies are. They're our project number and our employee. So these 2 pieces of information are going to give us our partial dependencies. What we do at second normal form is we break those out into their own tables. So we can make a project number table or a project table, and we can make an employee table. And we already know which fields go into them because we can look at the graph and know that our project table is going to have project and project name, and our employee is going to have employee number, name, job class, and charge per hour. Okay. Anything that is not a partial dependency gets kept in the original table. So we pulled out project name because we threw that into the project table. We pulled out employee name, job class, and charge per hour because we put those in the employee table, which means all we were left with was project number, employee number, and assigned hours. We changed our hours name to assigned hours because we're doing it per assignment, and we wanted to kind of define that with a little bit more words. Just calling it hours didn't really give us enough description. Yes, we understand that that transitive dependency still exists. That's okay. We want it there. We don't want it there, but we want it there. By the way, when you get to second normal form or changing to second normal form, you only really have to worry too much about this if your primary key is a composite key. If your primary key is not a composite key, you shouldn't have any partial dependencies because you shouldn't have two primary keys. You should only have one and everything should be related to it. You'll have transitive dependencies, which are fine, but you won't have any partial. So this step really only comes into play if you have a composite key and you have to split it like that. Let's talk about step 3. All right, so in step 3, we have to start with step 2. So again, we have our step 2 graph that we just used, or diagram that we just used for step 2. Step 3 is second normal form, but in this case, we remove our transitive dependencies. That's why we didn't mind that they were there, because step 3 is the part that gets rid of them. Step 2 gets rid of partial dependencies. Step 3 gets rid of transitive dependencies. So now we look for transitive dependencies, and we have one, this job class charge per hour thing. So the way we solve that, same thing we did with 2, pull it out into its own table. The determinant, the piece of information that the other field is dependent upon, is called the determinant. The determinant will be your primary key in your new table. So in this case, the determinant of job class charge per hour dependency is going to be the job class. So job class we're going to pull out as its primary key, and we're going to give charge per hour as the piece of information that's dependent upon it. Now, if you look at our dependency diagram over on the right, you can see there are no transitive dependencies, there are no partial dependencies, and I can really easily see where my primary keys are versus my regular attributes, and everything looks good. Okay, this is third normal form. Again, this is where most companies stop. They say, okay, I'm in third normal form, I'm good, I don't have to go on to fourth normal form, I don't have to worry about that, let's just keep moving. This is where a good designer will stop and reevaluate. So we're going to stop and we're going to look at what we have. We're going to look at the data that we have, and we're going to start making some evaluations. First off, we're going to look at our primary keys. Do they make sense? Should I maybe add a job code instead of the class so that I can have a number instead of a string? Remember, we don't like having strings as primary keys if we can avoid them. They really hurt with data entry and their strings, which are just annoying. So we're going to reevaluate our primary keys. We're going to look at our names and our naming conventions and make sure that you follow the same consistent naming convention throughout. If you're going to do a table underscore ID, you're going to do a table underscore ID for everything. Are all of your IDs caps? Are they all lowercase? Follow the same naming convention and make sure that you get that written down, that all of the naming conventions are similar. We're going to look at the concept of atomacy, or atomosity. I suppose you can pronounce it any way you want. It's the concept of the field cannot be subdivided. We have a field called employee name. An employee name can totally be subdivided into first, initial, and last. You might have a title as well. So employee name can totally be broken up. We need to split that into first name, last name, because we really don't want to keep that as a singular name. We talked about that, gosh, all the way back on chapter 1. So let's look at our data and make sure that we do have that attribute atomosity. Make sure that your attributes are all single valued. Let's look and see if there's any new attributes that we didn't already include, like social security number, or phone number, or address, things like that, things that we could have added in that for some reason we just didn't. You can ask the manager, the client, and you can go back and say, hey, why didn't you include address? They're like, well, we didn't need it for this report, but yeah, we have it and we'd like that information, and sure, it'd be great. So what other pieces of information do you need to add because they're not already added in your attributes? Are there any new relationships that you didn't think of before, like who is the manager of the project? So we had a project and we have employees who work on it, and we could have had a manager as a job class, but a manager could also be a different job class, like the database designer could be the manager as well. So we might want to do that. So let's figure out our other relationships that we haven't really looked at. We're going to refine our primary keys. And the concept here is also understanding data granularity, which is how much data do you have? How is your data broken into granules, into sections? When we talked about hours, remember we had hours in there. What does hours mean? Does hours mean the total amount of hours that you did for the entire project? Or was it the total amount of hours per day, per week, per month? How are we defining that? Look at your data and figure out if there is something else that you need to make a little more clear. Daily hours, something like that. The next is our time variant. Remember, we talked about history in chapter 5. So data, history, or time variance. We need to make sure we keep track of historical data. Is there something that we need to keep track of as far as how data changes? Can the start date change? Can the jobs change on the project itself? Is there any piece of information in here that you have not looked into as far as your time variant? And then the last piece of information that we want to look at is, can we derive any attributes? Is there any pieces of information that we might want to pull out into a derived field just because it'll make our queries easier and it'll make things better as far as performance? Yes, we go back and forth on this one. So you don't like derived fields because you can calculate them, but how much are you losing by trying to calculate them? So this is our final updated database dependency diagram. As you can see, we have 4 tables. We have created a project table that includes a manager ID. We added in the manager. We have the job table. We created a job code that was a number rather than a string. And we have a description and a charge per hour for that job code. For our employee, we have broken up their name into first and last and initial. We have also added in a hire date, and we've given them a job code. What is the code of the job that they do? We're assuming in this case that the employee only does one job. The database designer does not do electrical engineer. So we don't need to keep track of that. So we're going to kind of keep an eye on those things when we looked through and figure out whether or not that's something that we can do. In this case, we're going to call our job code associated with the user or with the employee. And then finally, we have our assignment, which is the data of all of our data. The other pieces of information are kind of lookup tables. They're kind of pieces of information about other information. This is our actual data. So for every given, we've created a new primary key called assign number. So it's primary key. It's just a surrogate primary key. We just created it. We have a date. We have an employee number. We have the assigned hours. And we have the charge per hour, and we have the assigned charge. So now we have related that employee number and project number. Instead of those being the primary key, we've created a new primary key. We revisited that primary key and figured out how could we make this better. At this point, we've also created the assigned charge, which is a calculated field. When you look at your dependency diagrams, you'll see all of your dependencies are functional dependencies. There are no partials, there are no transitives. We do have a calculated value for the assigned charge, but we knew we did that, so we're okay with that. We looked at it. A lot of times you can make these decisions because you realize they're a good choice to make. So we're going to talk for a minute about surrogate keys. We've talked about primary keys in general, and we've mentioned the concept of a surrogate key. There are a lot of reasons to use a unique identifier for your surrogate key rather than using a normal natural key or something else. We don't like to use useful names like first name, last name, something like that, because it doesn't prevent your duplicates. And sometimes those values can change. And remember, your primary key should never change. So you never want to use something that could possibly change. So you don't want to use really useful names. You don't want to use composite keys because if we're going to use it as a foreign key in another table, having composite keys makes that more difficult. So we always want to have a single value primary key if we can. If you have, like we did in our example, a composite key with our employee number and our project number, go ahead and make a surrogate key and just put both of those as foreign keys in your table. It works fine. You can still do the joins, you can still index across them, but this way you have a single value to reference for each row, and that's really important when you come with IDs. With a GUID or a unique identifier, it doesn't guarantee data integrity, but it does help. You're going to have a unique identifier no matter what when you use a GUID, but you could enter the data in twice. It's not going to stop you from doing that unless you add in indices or triggers or things like that to keep track. Be aware that that could happen and recognize when you're writing your data, I can't fix everything. I can't solve every user interest. And sometimes they're going to put in duplicate values. As long as I'm aware that it's going to happen, then when I'm designing my system, I can make sure to keep an eye out for those kind of things. Remember, when you're making your database, you always have these trade-offs, and you're going to use your professional judgment throughout. Is this a good idea? Is this a bad idea? Is there a reason to do this? So trust yourself, trust your gut. You know enough to make these decisions. So one of the other types of normal form that we're going to talk about is called voice cod normal form, BCNF. And BCNF is third normal form with making sure that every determinant is also a candidate key. Remember, a determinant is the thing that other attributes are dependent upon. So sometimes you'll get to this point, you've got up to third normal form, and then you have a composite key, or you have something that will create a determinant, and you'll recognize that there is a field that is dependent upon one of the two of your primary key, but not both. So you've gotten rid of any transient dependencies, but you found a dependency and you recognized it once you started looking at data. This is where BCNF comes in, and it says, look, you in this situation did a student ID with a staff ID, composite keys are allowed, and then you recognized that for each staff ID and class code, those work together. You may not have recognized it to begin with, that was going to be a thing, but it is. So we recognize that the class code and the staff ID are related, and our determinant is not a candidate key. Our staff ID is not a candidate key. So we need to kind of switch things around a little bit. So instead, we can switch it to being a student ID and a class code with the staff ID related to the class code, so that we're saying who is the staff member, who's the professor for a class, and that is separated into its own table, and that is going to solve that problem of having a determinant not being a candidate key. In this case, it is. We essentially got rid of that secondary dependency by putting it in as a secondary table. Most of your 3NF databases are going to be in BCNF anyway. You just need to look at each one of your individual tables directly and make sure that you didn't miss anything, okay? The other normal form that we're going to use is called fourth normal form. And fourth normal form is defined as third normal form, but it has no multi-valued dependencies. The example for this in the book is kind of a strange little piece of information that they gave you, where we had projects and organizations and whether or not employees worked for the Red Cross or the United Way, and some were nulls and some weren't, and it was kind of confusing. You want to just make sure that you don't have any multi-valued dependencies, so dependencies between multiple values that generally this isn't going to happen. You could end up with that in your database, but normally by the time you get to 3NF, you're already golden, you're good, and it's not a big deal. If you do find yourself in a situation where you are at 3NF and you still have multi-value dependencies, you have a large amount of nulls in your data, you might need to reevaluate cleaning up your data by building up new tables, pulling tables out. Like in this situation, we pulled out the organization as its own table, and then we related that with a service, and so we created a service concept to be able to relate the employee to the organization, as opposed to putting in, were you a Red Cross, were you a United Way, and things like that. It wasn't necessary to do it that way. Again, fourth normal form is not something that you're going to do a lot of. One of the examples in the homework does, and we did that on purpose. We purposely made a situation where you'd have to deal with fourth normal form. But in general, in the business world, you shouldn't be here. It doesn't usually happen to a point where you have to put it into fourth normal form, because third normal form should be good enough for you. Assuming that you looked at your data, you analyzed things, you kept an eye on your primary keys, you made sure that everything had as little data redundancy as possible. Okay, so once you get to this step, you realize that I have over-normalized my data, which you can do. You can totally over-normalize your data by having too much normalization. And we have to go backwards. We have to denormalize, unnormalize our data. What happens when you write your data in a theoretical world is that joins are just automatic and you don't think about time, but time does exist. We do have processing time. And every time you do a join, you're going to have that processing time. Every time that you do a calculation, you're going to have that processing time. And sometimes that processing time is so excessive that it's not worth the benefit of normalization at that point. So what we're going to do at this point is we stop and we denormalize our data, look at our data and see if I wanted to add some redundant data, how bad is that going to be? Is it going to be okay? If I wanted to have city state zip, well, I've got 15 customers that are all in city state zip. I normalized it out, but now I have to do a join every time I want a city state zip, and that's just annoying. I think I'm okay having a little bit of redundancy in there to benefit that cost. So that's where you start looking at the cost of the extra joins, the cost of the calculation, looking at how are you going to use it in a system, in the actual application you're going to use, and see about actually adding derived data in, aggregating data, which is compiling it or adding them together. You'll see about aggregation with 7.7 through 7.9. But and sometimes this is just how it has to be. You can have redundant data. It doesn't make your database bad. Again, databases are fluid, they're subjective, and you want to decide which cases do you really want to, which hill do you want to die on, which position do you really want to stand on for this. If you're doing a where clause, doing the lookup, if you remember your chapter homework from 7.4 through 7.6, you had that date difference in there, and that date difference you had to calculate and then do a where clause on it. Well, if it was already in the system, if we had included age anyway, you wouldn't have had to calculate it. You could have just done your where clause and moved on, and it would have made your query so much simpler. Sometimes making simpler queries is worth it to have somewhat redundant data or unnormalized, denormalized data. All right. So this summary of data modeling is actually in the front cover of your book as well. This just breaks down all the different steps that you're going to want to make while you're doing your data modeling. Looking at your business rules. Yes, write out your business rules. You should write them out, because the more you write them out, the more you'll visualize it, the more you'll see that one-to-many, many-to-many relationships that you've built in your business rules. When you're making your entities, make sure that you have naming conventions. I'm not a big stickler for naming conventions, but some people are. Some companies I've worked with are big sticklers on naming conventions. So make sure that you follow the naming conventions that you're supposed to follow. Make sure that your entities are single object. Make sure that your attributes are simple and single valued. Basic little things. And we've covered all of these up to this point. Just a quick summary. Make sure that you check through this whenever you're writing your databases. All right, so that was chapter 6, normalization. Quick overview. Normalization is processed to minimize data redundancy. That's what its purpose is. Make sure that you don't have data redundancy. When you go through data normalization, you go through 3 steps. You start with first normal form, then go to second, then go to third, and you're pretty good at third normal form. First normal form, you define your keys, define your dependencies, and make sure that all your attributes are dependent upon your primary key. Second normal form is first normal form, but get rid of those partial dependencies. Third normal form is second normal form, but get rid of the transient dependencies. And then fourth and Boyce Codd normal form are third normal form plus a little bit more. But we do denormalize, which is making your trade-offs between your data's redundancy and your processing speed. Let's look at your assignments. All right, for the review questions, terminology and dependency, those are really just answering terminology questions like what is. So those shouldn't be too difficult. 8 is actually doing the dependency diagram for the prescription data that they've given you. So you will have a dependency diagram in your review questions. Remember, go ahead and use the Dryo or the Lucid chart to be able to build those. You could scribble them out with just a box. You could use Microsoft Word's Smart Art or using boxes in there as well if you wanted to do your dependency diagram using those. And then for your problems. So I've included 4 problems. Number 1 is just build the dependency diagram from the ERD. They've given you the ERD, go build the dependency diagram. At third normal form. Remember, you're gonna have to go through all the forms, make your first, make your second, make your third, give me your third. You don't have to show me your first and second, but I am comparing it to the third normal form, assuming that you've gone through first and second. You could include some description of what you did at each of the first and second stages. And you may find yourself in third normal form just automatically. You'll look at the ERD and you'll build it in third normal form. Number 3, you are going to build your UML, so your relational schema, and your dependency diagram. Then you're going to go through and remove your partial dependencies, and you're going to update both of them. Then you're going to remove your transient dependencies and update both of them. So you should have 3 of each, or 6 total UML diagram at first, second, and third normal forms, for a total of 6 diagrams. For number 7, it's the dinner club. They've given you the table of data. You need to build your UML and then build your dependency diagram, and build your dependency diagram up to third normal form. Update your UML, and then go redraw your crow's foot. Your UML, remember, is going to have your attributes. Your crow's foot doesn't have to have attributes, it's just table names. So you don't have to worry about adding in the attributes for your crow's foot. And number 9 is a Excel spreadsheet of data. It's not very pretty. You're going to convert it from Excel, draw your dependency diagram, identify your multi-value dependencies, create your diagrams up to third normal form. Then you're going to get rid of that multi-value dependency. Remember how I said you were going to have at least one, and then go build your crow's foot. So a lot of times we build our crow's foot after we're finished, because if you build it early and then you go in and you change all your table names, it's annoying. So we like to build our crow's foot after we built our design diagram. In the formal sense, when I'm building personally, I will usually write my business rules and I will scribble out my design diagram, my crow's foot, and my UML, start adding fields, then I'll go normalize, then I'll make everything pretty. So that's kind of what they're saying here. You're going to create your UML, you're going to understand all of that kind of stuff, and then you're going to go build your crow's foot at the end and make it pretty. Okay, so hopefully you guys have fun with this one. Again, this is the last chapter before we start building actual SQL statements, getting into chapter 7, 8, and actually working with the database. So have fun, give me a call if you need anything, and I will talk to you soon.